Here's the question we're going to be taking a look at today, which is worth 45 marks. We're told that a triangle has one side of length 10 centimeters and another side of length x centimeters. The perimeter of this triangle is 26 centimeters. In part A, we're then given two diagrams showing different possible values of x. In both cases, we have to fill in the length of the third side. We know that the perimeter must be 26 centimeters, so if we take 10 centimeters and 5 centimeters away from 26, we're left with 11 centimeters, which is the length of the third side. For the second one, we do the exact same thing, but in this case we have 26 minus 10 minus 9, which leaves us with 7 centimeters, which again is the length of the third side. In part B, it asks us what type of triangle is shown in diagram A. Is it isosceles, equilateral, or scalene? So the correct answer is scalene, and the reason for this is that all the sides have different lengths, which is the definition of a scalene triangle. Moving on to part C, we're given a graph showing the area of the triangle for any value of x between 3 centimeters and 13 centimeters. We're also given a point A on the graph. In C part 1, we have to draw the axis of symmetry of the graph. So since the graph is symmetrical, that means that the halfway point on the x-axis is the halfway point of the graph. So halfway between 3 and 13 is 8, and from here we just draw a vertical line up. And that's the axis of symmetry of this graph. In part 2, we're told that A is the point on the graph with x is equal to 5. So it represents a triangle from diagram A. We have to use this point on our graph to estimate the area of the triangle in diagram A. While looking at our graph, we have the length of x on the x-axis and the area of the triangle on the y-axis. So if we draw a horizontal line across from A until we hit the y-axis, we can see that the area of this triangle is roughly 25 centimeters squared. Finally, in part 3, we have to plot the point B on the graph to represent the triangle in diagram B. We're also reminded that in diagram B, x is equal to 9. So to do this, we come across to 9 on the x-axis and draw a vertical line up until we hit the graph. The point at which this line cuts the graph is the point B. In part D, we're given a diagram showing the triangle with the biggest area. We have to construct this triangle in the space provided, showing our construction lines clearly. So the first place to start with this is by drawing the base, which is 10 centimeters long, using a ruler. Next, set your compass to 8 centimeters and swing an arc from the left point of the base. Repeat this with the right point of the base, and the point at which the two arcs cross is the other vertex of the triangle. So connect both ends of the base to this point and you'll end up with your triangle. Mine is only very rough, so yours should be a lot more accurate. Finally, in part E, we're again given the same diagram of this triangle, and we have to use the theorem of Pythagoras to find the value of h, which is the perpendicular height of this triangle. So Pythagoras' theorem says that a squared plus b squared is equal to c squared for a right angled triangle. In this case, a is 5, b is h, and c is 8, since 8 is the hypotenuse of the triangle. Multiplying this out, we get 25 plus h squared is equal to 64. From here, we take away 25 from both sides, leaving us with h squared on its own on the left, and we get h squared is equal to 39. Therefore, h is equal to the square root of 39, which is 6.2 centimeters, correct to 1 decimal place. That's the end of this question. I hope you guys found this solution video helpful. Thanks for watching, and I'll see you again.